Okay, thank you and welcome to the first session for ISBS on Monday, Australian Eastern Standard Time. I'm really excited, and I think we're quite lucky to have a really interesting and diverse group of people for this panel discussion on data science and how it sort of fits in sports biomechanics and probably sports science more generally. And we also have another 4 panelists that will be joining us in the evening, Australian time at 7 p.m. As I've sort of mentioned to each of the panelists, I think one of the best things about online conferences is just the fact that we have the ability to bring in different people to talk to our own communities, and this is a really wonderful example of that. So I'll go through and introduce each of the panelists. Deliberate by design is the difference in sort of discipline background across all 8 on these 2 panels, and a part of that is to show what I think how broad data science is and can be. So we've got Kristen Sanini, I'm sorry if I said that, I hope I said that, who's an associate professor of epidemiology and population health at Stanford University. Kristen's done some really wonderful things in terms of putting online resources out there and writing about science and writing about writing in science and statistics for a range of different audiences. And sort of more recently, she's been quite active in exploring statistics and statistical behaviour in sport, and has published a number of papers recently looking at certain practices. Frequently collaborates on sports medicine articles with collaborators, and also has featured as a seminar presenter for the International Society of Biomechanics in Sport seminar series that was run last year, I think. So welcome, Kristen, and thank you very much for being a part. We have Paul Wu. Paul's a senior lecturer and research fellow in modelling and data science at the Queensland University of Technology. Paul's originally from a background in electrical and computer engineering, which I think is great and very different, and has worked across disciplines ranging from ecology to aerospace and airports, focused research, and also sport. So, Paul, you're currently doing a lot of work at the moment with the Australian Institute of Sport, which is where I used to work, and it'd be really good to talk to you a little bit about some of that today. And we have Paul's colleague, is also from QUT. So Kerry Mengerson is a distinguished professor and the centre director at the QUT Centre for Data Science. Kerry's also Fellow of the Australian Academy of Science, Fellow of the Australian Academy of Social Sciences, an invited Fellow of the Queensland Academy of Arts and Sciences, and really wonderful to have you on the panel today, and has published some stuff in particularly helping to bring Bayesian statistics to sport a few years ago, and particularly does a lot of work working with applied groups. And the final panel member is Bill Johnson. So Bill's a senior research scientist with the Houston Astros Baseball Club, which I think is so cool. It's based in the US. You're actually a chartered professional engineer, both biomedical and electrical. And you've got a very multidisciplinary background. So information technologies in there, some work in the resource sector, as well as you've ended up in professional sport. And I think your PhD was one of the first ones that really brought state-of-the-art methods in a very interesting and robust way, like particularly around convolutional neural networks into biomechanics, and started to explore some of that synergies between developments in data science and deep learning and use and application in sports biomechanics. So like I think that I could probably turn individual conversations with each of these people into podcasts, and we're not going to have time to talk about everything with everybody today. But I'm not just really interested in bringing you as a group to us. I'm very proud of ISBS, and I'm very keen to show ISBS to you as a group. And there's a strong reason for that. So I'll just have one more minute just going through a few things. But basically, we've had everything from industry presentations run by Simi at this conference on artificial intelligence and Michaelis motion capture. So that's of strong interest to us as a society. We've had panelists on pathways for sports biomechanists, and one of them was a clinician, Tim McGrath, who works for a company called Pitch Ready. And he started off as a clinician in sports biomechanics research before realizing he needed to go and do a computer science degree to basically come up to speed on what the state of the art should be for biomechanics and where it's heading. And perhaps one of the most fascinating things was in our new investigator award last night, Australian time, 4 of the people who gave presentations, of those 4, 3 of them had machine learning integrated into their study designs and what they were doing. So there was basic feed-forward neural networks, there was recurrent neural networks, someone was using lasso regressions, I think there was also support vector machines that was blended in with some statistical parametric mapping, which is more sort of quantifying uncertainty with continuous data, sort of similar to functional data analysis. And the one person who didn't do stuff on machine learning actually has a master's. This is Marit Van Dyke, has a master's in artificial intelligence anyway. So the reason why I'm saying this is I think like we're a very strong society, and I think biomechanics is a very data competent society. And it sort of poses the question that if all of these people are doing these things at the moment, and that we have this capability to move into these spaces, maybe a good starting point would be a question of what is data science? Like, how is it actually different from, say, things that we pay a lot of attention to already, like statistics? But for me, having come from biomechanics, like, how is it different to what happens in biomechanics already? Like, and I know that might be a bit of an ambiguous question, but I think that would probably help to start off things. And I don't mind who wants to jump in first. So. Kerry?
So I'll go first, and I'm sure that others will be able to augment this as well. But to me, the great opportunity that we have now is that we come from our different discipline areas, but we have an opportunity now to really bring those different areas of analysis to bear on a particular challenge. And so we have different kinds of data sources that are quite different from what we had even 20 years ago. So all of the sensors that we have, and a lot combined with observational data, combined with expert information and so on. And we have, a lot of the imagery that's now available. So we have this deluge of data, but we also then have, so that's the data part, but then we have the science part, and the science part then is now being able to bring together these different areas. So to me, data science is bringing together, the capabilities of statistics and mathematics, and to bring together information science and computer science and e-research with the domain sciences. And so to me, data science really is this what emerges when we bring together these different disciplines. And so we have this combination of the disciplines, and then we have this emergent extra research that happens because of that.
I could keep talking, but I'm happy for someone else to.
I was going to dive in and build on that perhaps, and talk about the volume of data. I think biomechanics historically has encouraged islands of data, and that's what I found doing my research, was that the data was, if you like, stranded. It was like one research question had been answered for a research project. That data then was stayed, usually on somebody's hard drive. Whereas the difference now, I think, with data science methods is that that data is useful, and that we, with some QA, with some front end or some abstraction layer, that data is incredibly useful. And then I think that becomes that, I mean, I spend most of my time preparing the data, if you like, and so most of my work is not just capturing, not just but it's actually gathering that data in a form that I can then push into a model, for example.
It is like, it's an interesting thing, because I think, just for the participants' knowledge, so I've had a conversation with each of the panelists prior to doing this panel, and there's been a lot of stuff that's really fascinating that's emerged, which is why I was sort of indicating we probably won't be able to get through everything. But one of the things that you said, Bill, was that you spend a lot more time on that sort of, it's basically like data wrangling and preparation and the hard yakka side of dealing with data. And then often you end up needing to present something that's quite clear, more simply defined, to an audience that can understand things. And it just sort of, it's interesting, because I think, like, from my perspective, it seems like stuff that a lot of biomechanists probably are starting to do already, and sort of looking at potentially how the two disciplines, say, of biomechanics and then data science, have a lot of connections, is something that I've sort of found really interesting. And like, did you find it quite easy coming from computer science and that background into working with people from a biomechanics background, in terms of connecting and being able to talk with them?
Oh, I mean, so my research was interesting because I was essentially primarily sponsored or supervised by sports science at UWA, but then co-supervised by computer science, and physically, a 20-minute walk between those faculties. And I ended up noticing things like, not just that each discipline had its own lexicon, but it was almost more confusing than that, that each discipline has, sometimes it uses the same words to mean different things. And so that became, okay, so which conference or which journal am I putting this study up for? Because I need to be very, very clear about, and even like talking to different people from one end or the other, one discipline or the other. Okay, so I'm in this room today, so I need to explain it this way. And that was a big thing.
I think it's sort of interesting, because I think we're at an interesting point a little bit with when it comes to the creep of sort of it's not really creep, but the thing that Kerry alluded to, where you have the disciplinary expertise, and then you have this sort of proliferation and emergence of the data side of things. Sort of knowing when to pull the trigger on, this should be a capability uplift thing for myself, versus when do I know to try and find a person who's sort of more in that state of the art over there,
right,
that has that expertise. So
it's a real thing. So I've been talking, I liaise with like my peers in some of the other team sports in Houston, and we've been talking about, if we're hiring somebody, is that person a biomechanist? Is that person from a pure sports science or biomechanics background, or is that person from a pure computer science background? And increasingly what we're interested in is that we want to hire somebody that's a blend, and has at least taken some units that cross those disciplines. And even, can we influence academic programming in order to produce people that have that blend? And that's something we've been talking about locally.
I might open up to Paul and Kristen if they wanted to add anything.
Sure. I mean, I think increasingly, so kind of having spent a fair bit of time in aerospace, there's a whole systems perspective that you have the final objective that you want to get to. But there's usually of course, in that domain, it's a lot more engineering, mechanical engineering, the AI side of things. That's kind of where I work more so, and all the flight controls, aerodynamics. So bringing all those disciplines together is crucial. And I think what's happening now is that kind of extending past traditional systems thinking to complex systems, because the reality is that the human body and organizations are very complex, and there are different perspectives. Ignoring politics, that's also an important consideration too. But being able to bring that together, but also the modeling needs to be able to cater for these complex systems. So this is where we have opportunities of needing, I guess, the people with that kind of complex systems expertise, but also with specific. So, for example, this one of the projects we're working on. Okay, we have a lab of people working on neural networks for event detection, and then statisticians working on modeling of so what? How do we relate events to training load and how the player is progressing over a season? So it's kind of that bigger picture thinking combined with the individual areas of expertise to produce the value, I guess, the decision support, the risk reward trade-offs.
No, I kind of agree completely. I think I mean it's kind of the part of my line of questioning is sort of one for the benefit of the audience, but also for myself, because I'm sort of in a data science fellow position and have found myself a few times sort of looking at things and sort of saying immediate connections and similarities, and then you've probably contextualized some of the differences better than I had in my head, particularly around people who have that sort of adaptability and that sort of almost training and ability to operate in the complex system space, is something that, say, an individual discipline like sports biomechanics or any other discipline of sports science probably doesn't focus on as much, because they're a discipline and they have their work that they would be looking at, and particular training that's set up in that way. Did you want to add anything, Kristen?
I'll just echo what Bill said. I am not in a sports science or biomechanics. I'm in a medical school, but I would say there's some similarities, because in medicine, of course, data science, statistics, technical skills, if you have those, you can do a lot of things. And so I think increasingly we need students who are trained in both, who have some domain expertise, but also are able to pick up those technical skills. So I'm always encouraging students to take as much computer science, statistics, all of those technical skills in addition to their domain knowledge.
So maybe building from that idea of sort of the almost hybrid, combined set of skills idea, and kind of looking at that in the context of sport. Something that I think I've spoken with each of you a little bit about is, like, when it comes to sport, we have a really interesting interplay between research and practice, and I think sometimes it's that interplay that leads to confusion and decision making about doing certain things, either with data or from any perspective. But it's also an essential component of sport, because, as an example, in order to be able to test athletes and explore a particular concept, it's not as easy to just drag them out of their sort of representative environment and put them into a lab and then hope that what you do with them completely removed from their context will sort of work when we bring them back into their context. So there's a lot of competing motivations, trying to convince different types of people, like coaches and those sorts of things. And there was a paper that was actually written in our society's journal, so Sports Biomechanics, and it was coincidentally not by design for this panel, but great that it came out sort of a week before this happened. But it's titled "The Role of the Biomechanics Analyst in Swimming Training and Competition Analysis," and there's a paragraph in the abstract that says the role of swimming analyst as a part of a holistic team supporting high performance athletes has been expanding and needs to be distinguished from the job scope of a swimming researcher, which I think is quite interesting. So I've always had the perception that data science is sort of more set up for industry. Would that be correct? Or does data science also have like a place, in terms of helping the research side of an applied discipline as well? And I know that might be and again, like a difficult question to answer, but it's certainly something that I think sport and sports biomechanics will be trying to consider as it looks to figure out how to fit, the developments of data science into our own landscape.
I'll dive in if you like.
Yeah.
I think data science fits both. My experience here at the Astros is that we have some aspects of analytics that are well understood, have been in progress in baseball for some time, for example, and therefore you're kind of turning a handle, running a model with just different data from different games, or for example. And then you've got other aspects which do run at a completely different cadence. You're running, they are research questions there where you have some things that, you're throwing 10 ideas at the wall and hoping, 2 or 3 of them stick. And it is difficult to manage expectations. And, here it's a Sunday afternoon here and we don't have a game today, but a coach still called me, for example. And so how do you manage those? I mean, I'm just like constantly trying to manage expectations between, okay, here is something that I can deliver to you within a well understood amount of time, perhaps. And okay, well, that question could take 3 days. It could take 3 months to come back to you. And then it's about how you communicate that journey, I suppose. But yeah, I think data science spans both, or it does now, certainly.
Kerry?
Yeah, I'd just pick up on Bill's points and reiterate them, because I think that from me, there is this tension. I mean, you need to deliver something now, and all of us can talk to that. And you do the best you can with a set of skills, or with the set of skills that you can, from your team or from others that you can bring to bear on the problem. But I've, and maybe it's just me, but I've yet to meet a problem that I know the answer to it all. And it's sort of like, why hasn't somebody figured that out? It can be some part of the challenge that is really still a research problem. So you need, there is something that you extract from these challenges that go, okay, this actually needs some more development from the research side, and it's from the analysis side actually. So it's the new analytics tools and the new the new ways that we can make inferences, or the ways that, for example, how do we understand uncertainty, or how do we model this complexity, or how do we incorporate this kind of new data source with this other sort of data source? Whatever the question is, it's the how do we, or what happens when, that we need to then take out and then figure out as a research question. And so I think it's like you have this sort of scale, and people sit on different ends of the scale. But it's so some will be more on the research side, some will be more on the immediate application side. But there's this slider, and some people will sit more like statically at different points, and some people will sort of just slide along. But so it's a mix. But I think it's that real synergy that actually makes it an exciting area, because there is this challenge, this real research end of the sports science that is being developed in data science.
It is I think the whole, like the ability to potentially talk about these things, particularly with you as a group of 4, and then the next group, is quite important for sport, because there are some absolute non-negotiables, like with sport. For it to be impactful research or impactful practice, certain things have to stay quite locked down. But that often means that there can be a misalignment with, say, what the norms would be, and also what the best practice would be for, say, if you're going to conduct any type of research where you're quantifying uncertainty and trying to make comments using statistics that are more appropriate for population research. And I think, like, it's interesting, just from talking quite a bit with Kristen, about potentially sometimes with research, sort of it's not necessarily moderating expectations, but it's more understanding how to present what it is that you're actually wanting to do, and that you don't always have to use inferential statistics. Like, it's okay to do quite a descriptive, exploratory piece of work if that's sort of what supports the research question. Is that sort of correct, Kristen? Sorry.
Yeah, I mean, it's an interesting tension. I mean, I've worked for a long time as a statistician supporting projects in sports medicine, so I'm much more familiar with that domain. In the last few years, I've gotten pulled more into the sports science, sports performance side of things. And one of the things that's come out is that there does seem to be this tension between people who are going on to be practitioners, maybe looking at individual athletes, individual teams, versus other people are going on to research, and the training for that might be slightly different, or as you said, the expectations. And I think there's some, amount of pressure to publish. And so sometimes I think, letting students know that maybe a descriptive paper is more appropriate when you have a sample size of 7 than trying to make any inferences, right, would be a good message to get across, and that maybe not everybody has to publish X number of papers if you're not planning to go into academia, so that publication itself doesn't become this endpoint, which is one of my pet peeves, that when we're publishing for publishing's sake rather than for the sake of science.
It is like it's in, like, I think sport and exercise science and sports biomechanics needs both. Like, you kind of need the ability to produce research that encompasses the messiness of the sporting environment, because that's an important facet of it. But you also need well-constructed research that's designed to build evidence for a concept that might change policy or do something at a much larger scale. And I think it's almost like knowing how to sort of go about. I mean, this might be a good question for Paul. Sorry, I'm starting to put people on the spot, but but like, I mean, Paul, you set up projects with well, both as a part of your arrangement with the Australian Institute of Sport, but also you've worked with triathlon and you've worked with swimming. Like, are there certain ways that you go about framing research projects that have a really strong practice component to them, or that have that mess captured in them?
Yeah, that's a tough question, right? Because I think actually all real world projects are messy in some way, whether it's messy data, timelines, the messy problem in itself, right? Because, for example, if you want to capture injury risk, there's so much that goes into that. But having said that, I agree with what Kerry said earlier about having that sliding spectrum of abilities, from research through to the very practitioner. We need this for the next training session, kind of thing. So, for example, in swimming, right, we work with a physiologist, so that's on the very practical end, and he's also a sports scientist, which is really great. I think working with these people really affords a combined short-term, what do we need urgently, that kind of more well-defined scope, to also be able to develop together this, that is a critical problem that we just can't solve because of whether it's the data's not there at the moment, or whether there's methodological challenges, so we need new methods to try to capture this, or maybe a combination of both. And I think that's where, of course, this assumes that you have the time to put all these different projects. But luckily, us academics have infinite capacity. Where what we're trying to do now, right? We have this strategic partnership between the Australian Institute of Sport and Queensland Academy of Sport, where we have the industry research fellow and PhD students who are working with specific sports. So we kind of have this data science engine room here, so that we can learn from each other, collaborate on that. But then with the connection to specific sports. So what we're trying to do is kind of hit both the practical outcomes. Right? I think science should have some benefit for the real world. Paper is important, of course, for communication, but that shouldn't be just the final outcome.
Paul, if I may dive in directly and just skip over John completely, how do you manage how do you manage the tension between things like validation? Are you measuring? So Paul, how do I know that we're measuring what we think we're measuring? And then also, what I find useful to discuss is the acceptable error. Oh wow, okay, you want to do this at an affiliate where you barely have a cell phone, a mobile phone connection, and you want to conduct this kind of analysis. So your acceptable error is going to be, we have to discuss, it's going to be greater in this environment. But do you face the same kind of things? Are you measuring what you think you're measuring?
Excellent question. And that is a challenge, right? So sometimes, for example, we had a honor student who recently completed. So she was able to using a type of, depends who you talk to, hidden Markov model. Some claims machine learning, some claims stats. In reality, it's in both. But basically, to associate segments of the triathlon cycling race to energy systems. ATP, anaerobic, aerobic, and so on, and kind of, it was really powerful. But then, and so, okay, we can do some validation metrics on that data set in terms of, model predicted power output compared to the data. But then exactly like you said, right? Actually, at the end of the day, what you really want to do is go back to the lab and test, like, are these actual energy systems, and also match up to what we're trying to capture in terms of race. So this is from race data. But that requires further study. So that is almost like a PhD component, which I think that they would love to get the student for to do this kind of work. But so this is an example where we had a more focused practical outcome. So it was really nice because we were able to work with QAS and triathlon, and she was able to present it to the coach when we visited. So that was really cool. But then it's the kind of thing where the small project can help inform, what might be interesting now. It's kind of, we explored. So it's a kind of, we had the luxury here of being a more exploratory study, right? That, we could bring to bear some of these methods. It seems promising from the validation based on the data that we do have, but now from a physiological perspective, there are all these other parts to it that you need to bring together to be able to say, yes, this is a good model of physiological energy systems.
Yes, because even though we're working with these black box models, sometimes you still have to be able to join the dots.
Exactly. And so that's right. So it's kind of a black box, but also not that black box. So there's a latent state, which is unknown. But then they're also, it's all parameterized. But then which means also you need to validate that these parameters actually are describing what's happening.
Yeah.
Oh, I see Kerry's just unmuted.
No. I just wanted to say too that I think that, we also have to recognize that we all do this. I mean, you might have a way that you've developed or a method that you've developed, and if you're, or that we know about, and you're applying it to a challenge, working as a team with the domain experts and the practitioners is really important. But there can still be these chasms, and we know about these. So there can be, with the best will in the world, we can sort of take what we're doing, and we try to get it as close as we can to the practical problem. And with the best will in the world, the practitioners can sort of get as close as they can to understanding the issue. But we still need to have these ways of building the bridges, and there can still be the chasm. So how do we get the kinds of new methods and the new thinking into practice and embedded into practice? And I think that's still a challenge that many of us face, from this side of the chasm. And so that I think is an interesting question as well.
Just before anyone else jumps in, feel free, anyone in the audience, to put questions into the chat as well, because I'll be looking at those, and it's a unique opportunity to ask these four people questions that you perhaps wouldn't normally get the opportunity to ask of a group of these types of disciplines. I like the fact that we're sort of talking a lot about this, and it's something that's sort of quite an easy thing to move into conversations about, because like ISBS is a very practitioner and research driven society. And even just looking at the participant list now, there's a lot of people who work in high performance sport at the moment listening, as well as people who are either researchers in sports biomechanics or they're PhD students who are completing a sports biomechanics doctorate. So I think it is interesting, and it's a very useful thing to be talking about, and sort of hearing from the other side a little bit that it's not easy solving a lot of these problems. There is messiness. The messiness is okay, and it's probably that interdisciplinary mix and ability to connect with each other that's really important and helps to move the whole thing forwards. The question I have off the back of that is like, and I don't mean for it to come across as like it's not in any way a loaded question, but it can be really hard connecting with people in statistics and data science, not because you don't want to be a part of the work, but you have the same time problems that everybody has. You have your own metrics of performance as researchers and your focus points. So, often it might be a case of, I'd love to help, but I don't have the time, and it doesn't align with theoretically a research focus that you have or something like that. So I guess broadly, like what would help from our end to make it easier for connecting with you as a group, either like at individual levels or even at society levels? It could be at any level.
I'll jump in, John, since I'm an advocate of getting people in sports science to collaborate more with statisticians. So, a few things. I think I've been in a group and been the statistician embedded in a group for a really, really long time. And sometimes I describe my role in that group as sort of being the Grinch or the bearer of bad news. And so just recognizing that sometimes the statistician is the one that has to say things like, no, I don't see that in your data, what you were hoping to see, or no, the study cannot just have 30 people. But I've had a really positive experience working with this group because I've worked with them for a long time. There's a lot of mutual respect that, they feel like if they listen to me, that their science will have more integrity. And for me, I get to play with a lot of fun data and work with some really great people. So I think, those collaborations that's a model, I think, of how it should work. Establishing those collaborations can be tricky because, you have to pay statisticians. And often I know in sports science that the budgets are slim. But I'll say, like, I don't get paid a great deal always for some of these projects, but because the problems are interesting and the data is interesting, that you can grab my attention that way. And I think, John, something that you mentioned that I think is a really interesting one is this idea of biomechanics community or other communities in sports science getting together and pooling data in a standardized way like they do in genomics. I'll tell you want to get statisticians interested, you provide publicly available, standardized, large data sets those are interesting to data science people and statisticians, and tons of statisticians and data science people working in genomics, as you know. Well, why is that? There's really great data out there. So I think that's a way to draw people in. Is if you can't give them money, give them really cool data. Right?
Just before someone else jumps in, I'll put these papers in the chat for people to look at as well. But there's a paper from Sports Biomechanics also published in the last 12 months, which says the interlaboratory equivalents for lower limb kinematics and kinetics during unplanned sidestepping, and they're by people from the ISBS community. So it's got Jacqueline Alderson, John Donnelly, Mark Robinson, who's the chair of the next ISBS conference in Liverpool. But the whole point of this is to see whether or not the findings of this test of equivalence between labs can be important for data sharing and multi-center trials. And I think it is like, I think the biobank and some of these other areas of science that have worked quite hard to make things available, I think is quite an interesting thing that we're talking about it. It's appearing in our society's resources, and I think that's positive. Hearing from you that's a positive way moving forwards. But I might let other people jump in again because I don't want to talk too much. Did anybody?
Yeah, I'll jump in, and I know that that Paul will have something to say too about this. But I think what we're trying to do for our centre at a centre level is to create these sort of constellations, so that if we can get this critical mass of researchers and PhDs, and then we can have others who want to engage with that. So then you start to build up the sort of the capacity and also the entry points, so that that there can be that kind of broader engagement. And I know that Paul will talk to that. But I also wanted to talk about the importance of I think just communities of practice. I mean, you were saying how your society has such great skills and capability already. But it's also making the connections between those communities about topics that people may want to cover. And then there's opportunities, for example, to then partner with, for example, the Statistical Society of Australia, or we have an Australian data science network that we've created that connects the different research centres in data science around Australia. And so there's an opportunity to put a call for that group who's to put together a community of practice that can sort of match the other community of practice. So making those sorts of connections may be useful as well.
I think
Paul might want to comment on the mode at QT. I'm sorry, John, I interrupted.
No, but yeah, you feel free to jump in, Paul.
Okay, well, given Kerry's mentioned me so many times, I better say something. But yeah, absolutely. So one of the things we've done recently has been through this is the center precursor to the Center for Data Science, ACENS, where we have this collaboration between ourselves, the University of New South Wales, and some funding to hire some research assistants, basically, and in collaboration with AIS and AFL. So that was a great way to bring together people with different expertise, and then the time for someone to work on it, which is quite important. And now we're looking at a bunch of not just publications, but also what's really cool, because the person we're working with at AFL is their strength and conditioning coach as well. And so it's kind of this conduit to practical uptake. And so what's happening now is, as Kay was saying, we're kind of growing this so that we have not multiple projects, hopefully in this kind of arrangement, collaborative, interdisciplinary arrangement in this what's called a sports systems domain in the Center of Data Science, with connections to the Australian Data Science Network, to build up this critical mass. And actually, the other completely random thing is something Kerry has run is a data science challenge, data science workshop. You bring together. It can be very enticing for students as well to kind of open their eyes to this real world practical problem, the networks behind it, and kind of seed ideas and development, problem solving kind of thing in teams to try to, I guess, be the initial motivator for future research.
Which sort of that builds on that sort of it goes into more detail around that communities of practice and that the development of that being quite important, which I think is probably something useful for us to talk about as a community as we move forwards, because that could come in many forms and start at many start points, I guess. I'll just conscious we have 15 minutes left and there's a couple of questions from the audience that I might ask. I have more questions. I have many questions, but I'll give some people an opportunity to put their thoughts to the floor. So this is from Stuart McKeown and Naylor. He's on video there. He could probably wave, but he says, any advice for readers or reviewers? And I think this is fantastic. Who are less familiar with these types of methods that are coming out at the moment, and are there any quick ways to evaluate the quality of methods that we're reading about, especially as the number of machine learning papers starts to increase with applied topics? That I think is a great question. And
I'll jump in as the resident skeptic on things. Just because something has a fancy name, right? Often that doesn't mean it's doing what you think it's doing. So I always want to approach these things with a little bit of skepticism. If it's a model I haven't used before, or just because they used a fancy model, I'm going to check basic things like, do my ends add up? Does everything make sense? Does it pass the smell test? And those basic things that I wouldn't just, feel like, well, it sounds cool and that's the latest thing, and therefore I'm going to just, as a reviewer, assume they did it correctly. I would never make that assumption. But that's, again, my skeptical side.
Yeah, I'll jump in. I'm very happy for others too. But I wanted to say, just I take that point too, Kristen. But it's also the case that we know that there are other approaches that we don't know about, and so I think also going, okay, well, one of the things that I find challenging is when you get the response back that says, we've always done it this way, therefore you should do it this way, or that's not so, that we want to have a simple model because then we can explain it, and it doesn't fit, or it doesn't, it's not as useful as like something that's a little more complex.
Gary, I've never heard that in baseball at all. Both of those things. We've always done it this way. No, that doesn't.
No, never happens. Okay, all right. I'm completely out of the loop. Yeah. One of the things I was wondering about too in this is it's a challenge in many areas, and it goes both ways. So we can write about areas of sports, and we can be completely off the ballpark. And I'm wondering if, as we're talking about these communities of practice, if there's a way of thinking about having almost named panels on our society, in our societies, where people can get credit, if you want, for being, and I know it's part of just the whole, like, we've got to show what we do, but to get some sort of credit for being on this panel. And so then you get to name, like, if you're a reviewer as part of this panel, then, if you're part of this panel, then somebody from the other side can ask a question of, like, what do you think about just this part of it? Like, is this machine learning approach being conducted properly, or whatever it is? And the other person's actually doing the review. But then when it comes to writing something in the paper, it's about, we acknowledge the participation of the panel for blah, 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 so that then there's just this extra group that you can go and get some assurance of. And I'm wondering, Kristen, do you think that would work from your experience? Kind of,
yeah,
approach. I'm making it up, completely making it up.
I get, I take your point too, that yes, you don't want reviewers also coming back and saying, well, it's something I can't understand, so therefore I'm going to say don't do it. Right. I think going back to what we talked about, having standardized data, and Carrie, what you mentioned about challenges, this is actually a great way for people to learn new methods, right? If you have standardized data that's publicly available, and somebody's applied X methods with code that's publicly available, all of a sudden that gives you the opportunity to go and explore those new methods on real data. I would also encourage, I'm a big fan of simulating. So if there's any new method that comes out that I've got to review and I haven't used before, the first thing I'm going to do is I'm going to simulate some data and I'm going to figure out how it works for myself so that I have some trust. But having some, again, those communities where you have standardized data that's already been done with some code, where it becomes really easy for people to put their own hands around it and really see how those models work. Because until you actually run those models yourself on data, I feel like it's really hard to have a good intuition for exactly what they're doing. So any educational tools, yeah.
I mean, something I've noticed is a temptation to, for say a pool or a lake of data from a vendor to be accepted as ground truth. And so I think we need, as a society, need to challenge that. And it can't be, okay, if it is from a particular vendor, then it needs to be, it needs to pass certain tests. But that my guard goes up. Kristen, I love what you said.
That's
about
an example of vendor data. Being from academia, I'm less.
Yeah, I thought I was the one that kept saying no to everything, but you've volunteered that you have that, you do that too.
Yeah. I'm not familiar with vendor data. What would an example be?
Oh, where it's data being provided by one particular vendor, for example.
Okay.
Or a league, for example. I mean, so in baseball we have standard feeds from MLB, for example, that are provided by vendors. And it might be kinematics, or it might, or projectile trajectories, whatever. Where is the ground truth?
Right. Yeah, you always want to understand the source of your data. That's probably stats 101.1, right?
Yeah.
Know where your data are coming from.
Yeah. Is it valid to compare one ballpark against another ballpark, for example?
Yeah, that's a great question. Yeah.
I think talking about these data sets is really useful, because in many areas we know that there are the exemplar data sets, and the exemplar data sets are then the ones that are used as the baseline for comparing methods. So if you get a paper that has, so there's different kinds of papers. There can be the ones that have the new U-Butte method that hasn't yet been sort of showcased in other literature. And that's a different case, where then you do want to have your exemplar or your baseline data sets where they've compared it and that kind of thing. And then there's the ones that just I don't know about. And so there's many of those. And so, then that's where it has been then published somewhere else and developed. And I need to do the homework just to make sure that that's a fair call in how they're approaching it. But I think for all of us, there is this need for a data agency, or an agency in data science, to be able to ask the questions. And it's perfectly fine to go, can you explain this? Or, I need some more information about this, or, you need to justify this, or give references for that. And just as a reviewer, I think for all of us to feel the agency in doing that. And I guess that's what you were saying, Kristen, as well. And Paul, you find that all the time too.
I think if the author can explain to me in plain English what they did, I have a lot more trust that they actually know and understand what they did. So I'm a big fan of plain English and in statistical methods and scientific papers in general.
Right. We have one more question from Dwayne Knudsen, who's our ISBS president, and he's mentioned, he's asked, what percentage of variance in a key performance metric explainable by machine learning model or analytic model is expected for more routinely used communication to elite sport and coaches and athletes. And this is kind of interesting, because it's sort of, I guess, like, I'm not going to try to paraphrase Dwayne, but this idea of bringing models where we're quantifying uncertainty away from context where you use them in research, because they're designed to be talking about or commenting on things that come from a population, but you're now repurposing them in an environment where you're using them for fast decision making, or the uncertainty that comes out in a prediction from a machine learning model. Like, in those sort of practitioner spaces, is there a guide for what would be an acceptable level to make a decision. Dwayne, you feel free to unmute yourself as well if I've misinterpreted your question.
It's a combination question of, are we measuring what we think we're measuring? But then again, the second part that all the experts mentioned is how do we communicate this to an audience that wants an easy answer? And we try to give them the best we can when we think we can.
I might dive in real quick. I mean, I've got an example that I probably shouldn't talk about completely with named players, but I've tended to check models against historical data, and so I might have a conversation with a coach, and we've done this where we've had this sort of blind this game where the coach might say there's a player of interest, but won't tell me what the interest is, what they think is going on, and then I will report back of what the model is or what the data is telling me, and actually, if we're always agreeing, and this happened last season over 4 or 5 players, then that just builds credibility, but always being able to wind it back to a why. Yeah, for me, it was being able to go back to historical data and actually demonstrate that the model was doing what we thought it was doing.
Yeah, I think it's always a bit tricky because all models are wrong, some are useful. We try to explain it, but for us, I guess we've been doing a lot of communication in terms of what the probabilities are. So, for example, one of our research papers was about predicting winning times. So you can imagine that's a very challenging task, winning times in swimming. But it's kind of like, well, if you swam this time, what is the probability you might win? And then that's kind of a different way to support, and then being able to make comparisons between different, times of different athletes and that kind of thing. And that could be, I guess, one of the ways to try to communicate some of the outcomes.
We have a few minutes left, and I've got one more question that I'll just throw out there, and it's a very broad one. But if there's one thing that you would like sports biomechanics to know about anything to do with data, what would it be? And then we might close the session, and I might be forced to close the session, actually.
I would say you never have enough bandwidth, and your processing machine is never big enough.
I'm going to add, don't be intimidated by either statistics or statistical programming or data science, because I think a lot of applied students, maybe not so much in biomechanics, but maybe in other areas of sports science, can get intimidated by numbers, programming. You're all capable of doing statistical programming, and I encourage you to not, to be confident in your ability to pick that up. Super, super useful to be able to have those skills.
Thanks very much.
Go, Paul.
Actually, mine was just more so that I think it's a very exciting time. So I read a recent news article on ABC about the Chinese using aerodynamic lab, basically from analyzing aerodynamics of missiles to analyze aerodynamics of swimmers. But the interesting part is, well, what do you do with the data afterwards? And I think this is where there are a lot of exciting opportunities in biomechanics and data science going forward.
And I'll add that the area is always evolving. I think sports science and biomechanics is just such a cool area right now. And I think also the data science part is also evolving so quickly. And we know that we need to have this continual learning. And so being open to developing new methods and developing the teams that we need to be able to apply those. But also there's one of the things we're doing is trying to come up with sort of personalized learning systems, so that there's a lot of material online at the moment, and it's what material should you should you use or direct yourself to for upskilling? So if you want to do that, then can we come up with a way of going, okay, here's all the material, here are the trusted sources. And we're doing this with the United Nations at the moment. So here are the trusted sources of courses. Here are what the courses actually entail. This is where I'm at the moment. This is where I want to get to. And then you basically get a shopping list of courses that are going to be recommended to you. And then you can develop your own sort of personalized program for learning. But I think this ongoing learning is something that we're all going to just we all have to embrace. Yeah.
Mm. No, I mean, we could absolutely, I'm ready for takeoff to talk for another 10 minutes just on that particular topic. But we do have another session starting now. So I think it's fair to the presenters and also to this group to close this, but also say thank you so much for joining our conference and for being a part of this panel. I hope all of the participants took something away from that that was useful, and I hope it's not the last that we see all of you. I said in the pre-conference bit where we were just having a chat, I think this online bit is really cool. And at future face-to-face conferences, being able to do this sort of stuff for just a one-off session where we might not normally see people like Bill or Kristen or Kerry or Paul would be amazing. So thank you, everybody, and have a wonderful morning, afternoon, or evening.
Thanks
for organizing, John.
Thank you.
Thanks,
Yeah,
John.
thank you, John.
Thanks, John.
Bye.
Bye.
Thank you all. Bye.